Okay, let us proceed to the next question. We have discussed up until question number 3b, right? So now C. Let's find out the equation of the regression line. Right, whenever they ask this kind of question, they want an equation of regression line, or they want you to fit a regression line. It means that they want you to find to give the regression model, of right, y equal to beta naught hat plus beta 1 hat x. They want you to give this model, which later will also tell us the best line, right? So to find this model, to make this model complete, we will need to find beta naught and beta 1. So again, what is the formula of beta naught and what is the formula of beta 1? Okay, so beta naught, the formula of beta naught is equal to y bar minus beta 1 hat times x bar. Again, as you can see, to calculate beta naught, we'll need beta 1. So let's go and calculate beta 1 first. So beta 1 is equal to Sxy over Sxx. Right? Sxy over Sxx, which already made available. Okay. So equal to Sxy 967 over Sxx 650, right? We already calculated this previously. So this will be equal to beta 1, which is 1.488. Right? Try to calculate it. 1.488. As for beta naught, now that we have beta 1, right, which is 1.88 here, so we can calculate it. Right? So let's calculate for beta 1. So equal to, okay, y hat, which is y hat here, 13633. So we have 136.33 minus, with beta 1, which is 1.488, right, times with x bar, times with our x bar, which is 51, right, 51, which will give us the beta naught value of 60.46, right, 60.46. Now that we have beta naught and also beta 1, the next thing to do is to put it in our formula, put it in our model. Okay, so let's write it down. So the model is y hat equal to beta naught hat, which is 60.46 plus with beta 1, 1.488. So is this the answer? Not yet. Don't forget that in the model we have x at the end. So you'll need to put x at the end. So this how to write down the model or the regression line. Okay. Now what is the next question? Find the equation, and then they want us to interpret, right? For question D, interpret the slope in this regression line. First of all, where is the slope? Right, you have two values here, this and this. So where is the slope? Is it 60.46 or 1.488? 60.46 is beta naught, which is also equal to the y-intercept, and 1.488 is beta 1, which is also equal to the slope, right? So 1.488, what we can say, right, with this slope, right? So by looking at this slope, we'll know that the value is positive. Okay, among the things that we can say, this value is positive, so we can imagine that later when you draw a graph, you will get a sort of a positive kind of relationship, right? Because it is positive. And another thing that we can say is that one unit change in this value of x will change 1.488 unit in y. Now we have discussed this before in a previous video. You can try to look at it again in how to interpret this. So one unit change in x will change 1.488 unit in y. That is another thing that we can say, right? In this for the slope. Okay. So what else? Question. Okay, now for this one, do the data support existence of linear relationship between H and blood pressure? Test using alpha 0.05. Now, whenever they want us to test, it means that you need to conduct hypothesis testing. And for you to conduct hypothesis testing, you'll need to have for our syllabus 5 steps. Okay, 5 steps. So the first step is to write down the hypothesis H null and H1. So for H null and H1, right, you can either write down there is no linear relationship and there is a linear relationship, right, between H and blood pressure, or to put it more in a more simple way, right, statistically, we can write it down beta 1 equal to 0, which indicate no relationship, and beta 1 not equal to 0, which indicate there's a relationship. Okay, so why beta 1 equal to 0 meaning no relationship, and why beta 1 not equal to 0 meaning there's a relationship? Please refer to the previous video. So number 2, right, what will be our second step? Our second step, right, is to find the F value, the F statistic. And in order to find the F statistic, we are going to create the ANOVA table, the F statistic table. Okay, so let's draw down the table. So we are going to have 5 columns. Okay, so let me draw it down first. We are going to have 5 columns. So we are going to have the column of source. Yes, source, and we are going to have the value the column of SS, sum of square, and then we have DF for degree of freedom, and then we have MS for mean square, and then we have F, which is the value that we want to find out. Okay, so for the rows, we are going to have another 3 rows, right? 1, 2, and 3. So this is the table. Okay, so the source. The first one will be regression. The second one will be the error, and the last one will be the total. Right? So for the SS, for the sum of square, right? For regression, right? Simply multiply between beta 1 and SXY. Okay, so beta 1, which is 1.488, okay, times with SXY value, which is 967, will give you the value of 1438.6. Right, let me make it bigger, easier for me to write it down. 1438.6, or yeah, 6. And then we have the total. Right, the total here, the SS for total is equal to SYY. What is the value of SYY? Let's look at it again. 1562. Okay, we have 1562. Then for the error, simply subtract between total and regression. 1562 minus 1438.4, which will give us 123.4. Okay, so that is the regression. Next, we have the degree of freedom. Degree of freedom, for the first one, it is k minus 1 or 2 minus 1 or 1 fixed. Integration is always 1. Next, the error is n minus k. Our n just now is 9, right? We have 9 respondent minus k. Our k here on the groups is 2, x and y, right? So 9 minus 2 equal to 7. And lastly, n minus 1 or 9 minus 1 equal to 8. You can see whether it is correct or not, because this plus with this should get this. So 1 plus 7 equal to 8 is correct. Next is to find the MS. How to find MS? By dividing SS with DF. Okay, dividing SS with DF. So the first one, SSR here, divide with 1 will give us the same value of 1438.6. And 123.4 over 7 will give us 17.63. Okay, and ultimately we want to find the F value, which is this one. To find the F value, we need to divide between the MS, which is 1438.6 over 17.63. Okay, so divide it and you should get 81.61. There you have it. The F value for this equation is 81.61. What is the third step? The third step will be the step of finding the F critical. So to find the F critical, right, we'll need three things, three value, which is the first one is the alpha. For this case is 0.05. And we have this another two value, which is this two, DF, 1 and 7, right? So it is actually 1, 7. So next we are going to refer with the F table, right? Because now we are using 0.05, so we are going to look at the table of 0.05. 0.05. Okay, look at the table. Okay, So we have 0.05 here. This is a table of 0.05. You can look at it. This is table of 0.05, 1 and 7. So which will give us 5.581, right? This is it, 5.581. 591, sorry, 5.591. Okay, so let's go back to our solution. 5.591. Okay, after we obtain F and F critical, the next step is to compare between those values. So our F, so that was the first step. Our F is equal to 81.61, which is more than the FCV of 5.591. Right? When it is more than, we say reject H null. So when you say reject H null, right? What is the conclusion, which is the fifth step? The conclusion, let's refer back to the first step, which is this. We'll say reject this, meaning that there is a linear relationship. Okay, you can just quote back the question. See, the question asks us, do the data support the existence of linear relationship between the H and block? You can either make your own statement, right? So, or you can just answer yes, right? You can just answer yes, the data do support the existence of linear relationship, right? Relationship between H and blood pressure. Right. So that is the answer for question 3E. Okay. Now let's proceed. How would you know a regression equation is suitable to be used in making prediction? How would you know that? So we know that the equation that we generate, the equation that we calculate, which is where is it? This equation is suitable, okay, in making a prediction when we see the value of r squared. The value of r squared is close to 1, right? Is actually high. So for this case, what is the value of r squared? Okay, we know that our r that we have calculated just now, previously. Okay, let me write it here. We know that our r, right, our r is equal to 0.9597. So when the value of r is 0.9597, when you square it, you should get 0.921, right? So the r squared is 0.9597 being squared, which will give us 0.921. In other words, right, r squared usually being presented in a form of percentage, 92%. 0.1%. So we can say that 92.1% of things that happen in the value of blood pressure being influenced by age. In other words, the model is sufficient to be used in making a prediction. So that's why we can say that we would know a regression line is suitable by looking at the value of r squared. So when the value of r squared is big enough, we'll know that the regression equation can make a better prediction, right? Because the variation being explained by x is big enough. If not, you need to find another factor in order for us to do a prediction on y, on the blood pressure, right? So for this case, that is the answer. Now G, what is the difference between the relationship calculated in B compared in E? So B, just now, we calculate for R. And the interpretation is there's a strong and positive relationship. Meaning we'll say that there's a linear relationship, right? That is strong and positive. As for E, we'll also come up with the conclusion that yes, there is a linear relationship. So both of this answer is actually giving the same conclusion. So what is the difference between R and hypothesis testing in regression? Okay, so to answer that, we already actually discussed that in detail in the previous video, but I just remind you again. R here, right, we obtain this R by calculating data available in the equation. So basically this R here being generated based on the data of a sample only. So this R actually represent, right, the value of R, which is 9597 here, actually only represent the 9 respondent, right? The sample. We have the 9 respondent, right? The sample. That R only represent them. So up until this point, we can't really yet say that there's actually, in general, there's actually a relationship between blood pressure and age, or age and blood pressure. Why? Because the restriction of R here is that it can only be applied to the sample. In order for us to generalize the result here, we'll need to first conduct the hypothesis testing. As you may know, hypothesis testing is a type of statistical inference that use sample to later make a conclusion on bigger population. So that's why we'll have these two, B, which is R, and later E, which is hypothesis testing. Because if you stop at B, you will not be able to talk about the relationship between age and blood pressure outside your sample. Okay, that is the answer of F. Now G. The difference is that R here is for sample, the answer for sample, and E here is the answer that can be used to be generalized for the population. Okay, and lastly, what is the relationship between correlation and regression? All right, so this is also being discussed before. Correlation itself is a method that which is R, right? Correlation here is R. It is actually a method, an approach to find the relationship, the strength and magnitude, the strength and direction of between two variables. Okay, and as for regression, right, it is an approach, the same approach that later talk about relationship, and not just that, it go further in developing a model and making a prediction. Basically, as we have discussed before, regression, correlation is actually a part of regression, right? Correlation is part of regression. Okay, so that is the discussion on tutorial. So good luck for your exam later. Thank you.